In this video, we will be discussing NCERT solutions for question number 9 and 10 in chapter 3 current electricity. Question number 9, determine the current in each branch of the network shown in the figure below. Here is a figure for you. It's a Wheatstone bridge, but you can see this is unbalanced because this ratio 10 to 5 is 2 and this ratio is 1 by 2. So this is an unbalanced Wheatstone bridge. The current distribution we have taken, the question is on the screen for you. For solution, we cannot use the Wheatstone balance condition. We will have to solve this question by using Kirchhoff's laws. The current distribution wherein we have used junction rule is as shown. This is current I. We have taken the current drawn from the source as I, divided into two parts, I1 in this branch AB and remaining I minus I1 in this branch. I1 is again divided into two parts, I2 here and I1 minus I2 here. So here you get back that current I. Now let's see how do we solve this question. Using loop rule in ABDA. Remember, we have to take a closed loop in any direction. Any closed loop, any direction. So first loop which we are taking is ABDA. Here the condition is 10I1 plus 5I2 minus 5I minus I1 equal to 0. This simplifies to this 5I minus 15I1 minus 5I2 equal to 0. Then in loop BCDB, this is another loop we are taking. So first is BC, you can write the condition for it. 5 ohm into I1 minus I2 minus 10 into current is I minus I1 plus I2, I minus I1 plus I2 minus 5I2 equal to 0. This simplifies to 10I minus 15I1 plus 20I2 equal to 0. These are equations 1 and 2. We will be using these equations. And then we have to use another loop ABCEA. There you can write the condition by using the loop rule and simplify the equation. This is equation number 3. We will be using these equations to get the values of the currents in different branches. Equation 1 leads you to 10I1 equal to 10I equal to 30I1 plus 10I2. Second equation gives you 10I equal to 15I1 minus 20I2. And third equation gives you 10I equal to minus 15I1 plus 5I2 plus 10. Left hand side in all the three equations is the same. So you can write from 4 and 5, we get 30I1 plus 10I2. 30I1 plus 10I2 equal to this 15I1 minus 20I2, which implies I1 equal to minus I2. From 5 and 6 likewise the left hand sides are same, so you can equate the right hand sides to get this condition. Rearranging, you can get 30I1 equal to 25I2 plus 10 or 30 into minus 2I2 because I1 is already shown to be minus 2I2 equal to 25I2 plus 10, which gives you the value of I2 on simplification. So I1 is minus 2I2, that gives you value of I1, and you can also calculate I, substituting the values of I1 and I2. So you get the current in different branches as I, current in BC, current in AD and current in DC as shown on the screen. Question number 10. In a meter bridge figure we have here, it's given to us. The balance point is found to be 39.5 centimeter from end A. 39.5 centimeter. When the resistor Y is 12.5 ohms, this is 12.5, determine the resistance of X. Y are the connections between resistors in Wheatstone or meter bridge made of thick copper strips. You also have to find the balance point if X and Y are interchanged. What will happen if galvanometer and cell are interchanged? Means the cell we connect in place of galvanometer and galvanometer we connect across AC. Would the galvanometer show any current? Because previously it was balanced, means there was no current. Now in changed conditions, will we get any current or not? We have to justify the result. For solution, you have the diagram here. It's given that Y is 12.5 ohms, L1, this is L1, 39.5. So that gives you DC equal to 100 minus L1 equal to 60.5 centimeter. For ballast bridge, we have X over Y equal to L1 over L2 or L1 over 100 minus L1. So that gives you X equal to Y into this, just simple cross multiplication. Substituting the values, you get X as 8.2 ohms. The resistances of the connecting wires are not taken into consideration. We don't have these values in any calculation when you derive the balance condition. Hence, the resistance must be very small. That is why we make use of thick copper strips, because we know thick copper strips means larger area of cross section and very small resistors, which we neglect. For B part, we have X over Y equal to 39.5 over 60.5 and Y over X is equal to L2 over 100 minus L2. When you interchange X and Y, you get a new equation. We take balancing length as L2 in this case. Multiply 1 and 2. You can see left hand sides are reciprocals. So product of left hand sides is 1, which is written here. Product of right hand sides L2 over 100 minus L2 into this term 39.5 over 60.5. Calculations lead you to L2 equal to 60.5 centimeter. For C part, interchanging cell and galvanometer in a balance bridge does not alter the balance condition. This you can check if you redraw the Wheatstone bridge diagram and write the balance condition P over Q equal to R over S. Interchanging gives you the same result. So galvanometer will again not show any deflection. You may subscribe to our YouTube channel CBSE 042 for further notifications about the future videos. Should you have any feedback, you can write to ikg54@yahoo.co.in. Visit our blog for notes on different topics in physics. Happy learning. Thanks for watching.